are there inbuilt functions which work on the entire vector and, let's say return the sum, or whatever, square, or mean, or minimum or maximum? I mean, of course there are, there are a lot of inbuilt functions which are very useful. Inbuilt functions like, so let me discuss sum, min, max, mean, cumulative sum, okay, and then absolute value, and then sample, and then sort. Okay, so I mean there are more actually, I mean I'm just listed some of them which are kind of useful. So how to use actually R help? I mean, if you want, let's say if you don't know what to do with the sum, how to use help from R? Obviously you can search internet, that is there's a lot of stuff on the internet. I mean, the moment you're going to just type any query, you will get a lot of help on that. Okay, so this is a very useful resource. Okay, and I'll also try to post some documents on Piazza which can help you with R programming. Okay, so so basically if you want to help for this function sum, then you can put a question mark and then sum. Okay, and then just run. Okay, so you will find that there's a documentation that you will see here, which tells you what this function do. Okay, but obviously it's an inbuilt function, name is sum, so I mean we know what it will do. Okay, so if you just, let's say for example, sum 1:5, it will return the sum of first 5 natural numbers. You can also do it in this way. Okay, and you can also, by the way, put vectors in it, rather than writing it like this. You can put C 278 or whatever you want. Okay, and it will find the sum. Okay, so let's just run this, and run this on some vector, and let's figure out the sum. So suppose I have scores of, let's say 5 students. You can just put some scores arbitrarily. Okay, 89, 32, 78, and 65. Okay, so I have this score data. Okay, and now what I'm going to do is I want, what is the sum of these scores of the students. So I can just put scores here. Okay, and this is the inbuilt function, and this is the variable that I have created. Okay, which is this vector. So I'm going to just put that here, and figure out the sum of these scores, and that's 329. Okay, so if you just add them up, you'll get 329. Okay, and if you want the minimum score, okay, so you can see the minimum is 32. Okay, so let's see what we are going to get if you want to just use this inbuilt function min. Okay, again you can put a question mark and put min here if you want to see the documentation. Okay, but and you can see the result is as expected. Okay, so these are very convenient functions. Okay, I mean, and they are appropriately named. Okay, so that is why I said that it's good to use the names that are sensible, so that you know what that particular variable contains. Okay, so max of scores is 89. Okay, and what else? Mean. Okay, so mean is going to give you the arithmetic mean. Okay, the average scores. Okay, so let's just run this. Okay, so it will be this sum of this divided by the length of this. Okay, so if you want to quickly check, you can take the sum, okay, and divided by the length, okay, of scores. Okay, and run this, and you should get the same value, obviously. Okay, and then you have cumulative sum. So what does cumulative sum do? Basically, it will create another vector. Okay, so So its first entry will be 65, okay, the cumulative sum. The second entry will be 65 plus 89. The third entry will be 65 plus 89 plus 32. Okay, the fourth entry will be 65 plus 89 plus 32 plus 78, and so on and so forth. So obviously this is one thing that can be useful later on. Let's say if we are checking for weak law of large number or law of large numbers, basically when the sample size increases, what happens to the sample mean. So there will be using the cumulative sum function to figure out like as the sample size increases, what will be the sum. Okay, so that we can then divide it by the uh, you know the sample size to figure out the mean as a function of the sample size. Okay, so this is a useful function. Okay, and then you can divide well, okay, this is okay. So this is the cumulative sum function. Okay, now let's say if I want to figure out the cumulative means. Okay, so what that means is that the first entry is 65, the second entry is 65 plus 89 by 2, the third entry is 65 plus 89 plus 32 by 3, and so on and so forth. So can I do that using, is there a function cumulative? Oh, so there is an inbuilt function that you can use. Otherwise you could have also done this. Okay, let me just just divide it by what? So what do you think I should divide this by so that I get the cumulative means? And let me also check cumulative means. What do you think I should divide this by so that I get cumulative means and not the cumulative sum? What do you think? So I want to divide by entry. I want to divide by the length, right? So I want to divide 65 by 1. I want to divide 65 plus 89 by 2. I want to divide 65 plus 89 by plus 32 by 3, and so on and so forth. So what should I put here so that I get cumulative means? This is a vector. So element by element, I want this division. So what should I put there? What do you think? Okay, I mean, can you tell me some R code that I put here which will give me that? Yeah, very good. Okay, so it is 1:5. So if you put 1:5, you'll get it. Okay, so it's better if you put 1:2 length of scores. Okay, the reason is because you don't want to keep changing this code again and again. So the moment you just, if you change this, then if you put 5 here, okay, then you also have to change this. Okay, so you don't want to do that. So I'll put 1:2 length. Okay, it will benefit because it will benefit you because then you just need to change this and you don't have to make any changes later. Okay, so so let me run this. Okay, and then I'm going to just use this inbuilt function and I'll just quickly check if I'm going to get the same thing or not. Okay, let's run this. Okay, oh, okay, so that's good. So there is another function which does the same thing. Inbuilt function means, so you don't have to do this, you can actually use this one. Okay, okay, so okay, is there a function median? Let me check. Median, looks like there is one. Let's run this. Okay, so it will return the median value. So what is the median value here? What do you think is the median value? What is the median of scores? What is the median? 65. That's right. Okay, so it's 65. Okay, so we should get 65, right? Okay, let's run this. Okay, please note that 32 is not the median. It's not that. So you'll basically, median is the middle, the value at the middle position of the sorted vector. Okay, so first it's going to sort it and then it's going to choose the middle position. Okay, so median scores should be 65, and indeed it is 65. Okay, so sample. Okay, let's use sort. Okay, so sort of scores. Okay, you can see that R also helps you here, in the sense that when you're writing a function, it tells you what are the inputs. Okay, so this is actually the essential input. So if you don't supply this, it will give you an error. Okay, so you have to supply the first one. Okay, you can choose not to supply the second one, because so okay, you can choose not to supply the second one, because in the second one, okay, let me just check sort. Okay, in the second one, the default is that the decreasing is false. So decreasing order is false by default. Okay, so what that means is it will sort the scores in an increasing order. Okay, so let me just run this, and you can see that it is an increasing order. Let's say if you want it in a decreasing order, then you can just say that decreasing is equal to true. Okay, you can put t here. Okay, and let's run this. Now it's in the descending order. Is that clear? Is that fine? Okay, so if you want, you can use this capital T, or if you want, you can use true like this. Okay, please don't use this. Okay, that's not the right thing. I mean, it's sensitive to the to the size of the letters. Okay, so you have to use this. Okay, or you can use this. Okay, so you can just read the documentation, and you'll get it. Okay. Okay, so we have sorted it. What else do we want to do? Absolute value sample. Okay, so let's first do sample. Okay, and then I'll tell you about the absolute value. Sample. So let's say I want to sample from these scores, or let's say I just simply put sample scores. Okay, then what it's going to do is this, that it's going to give you a permutation of these scores. Okay, some permutation of these scores. Okay, so let me run this. So this is a permutation, right? I mean, it's one permutation. If I run this again, I'll get another permutation. Okay, if I run this again, so it is going to randomly pick a permutation and will give you that. Okay, so it's not that every time it's going to give you I mean, it's not that it's always going to happen that every time you're going to get different permutation. It's possible that you might get the same permutation again, because it's just going to randomly pick one of the permutations and return that. Is that clear to everyone? That's what sample is going to do. Is this fine? Okay, now suppose you want to sample from these scores, let us say two of them. Okay, so again, let me just check. So size is basically by default it is the entire vector. Okay, so what you can do is you can just specify the size. Suppose I want two scores out of these. I want to randomly pick two scores out of these set of scores. Okay, so I'll get some subset. Okay, and notice that by default replace is false. Okay, so by default replace is false. So what that means is it is without replacement. Okay, so if it is without replacement, what do you think I should get if I put 7 here? It's without replacement. You're doing the sampling without replacement, and you want a vector of size 7 from a vector that contains 5 elements. Well, it should give you an error, right? I mean, you can't do without replacement. But what you can do is this. that you can set replace equal to true. Okay, and now if you run this, it will give you, a random sample. Okay, and obviously this is possible because now you're doing the sampling with replacement. Is that clear? Is that clear?
Yes, sir.
Okay. Okay. So now let me do one thing. Let me take scores and subtract from that mean scores. Okay, and I'll get this. Is that okay? Right? Okay. So because I've just subtracted from it mean scores. Okay. Now let me divide this by standard deviation of the scores. Okay. So again, there is an inbuilt function SD which will do that. Okay. This technique is known as standardization. Okay. So let's run this. Okay. Now, can you tell me what will I get if I find the standard deviation of this? If I find the standard deviation of this vector, what will I get? Do you know what standardization is? Subtract the mean and then divide by, yeah, you should get one, right? You should get one because it's a standardized version. So if you now find the standard deviation of this revised vector, okay, so let me call this standardized scores. Okay, and now let me find the standard deviation of standardized scores. Okay, so I should get one. Okay, let's run this. Well, as expected. Okay, let's just quickly do absolute value. Okay, now if you look at these standardized scores, there are some negative values in it, right? Yes. Now if I want everything in absolute terms, okay, I can just use this inbuilt function ABS and I'll get the absolute value of all of them. Is that fine? Okay, and then if I want the sum of the absolute values, I can also do that. Or if I want to find the mean of the absolute values, then I can also do that. Okay,